for coming out tonight for our virtual Star Talk. We are joined this evening by Kurt Spivey from the YSU Ward Beecher Planetarium with the Department of Physics, Astronomy, Geology, and Environmental Sciences. Did I get all those?
Yes, pages. You got it.
Pages. Okay. So Ward Beecher Planetarium, it's a wonderful resource in the Youngstown area. I'll let Kurt speak a little bit about it here before we get started. But he will be using a couple of resources I shared in the email with you, Stellarium and Skynet. So feel free, you can use those to take a look where you are.
Well, we better not use Skynet. That was the thing in Blade Runner.
Skynet, yeah, let's not use Skynet. It looks like Sally's already found her space. She's ready to go. So, Kurt, I'll go ahead and turn it over to you. Take it away.
Very good. It's actually skymaps.com.
I was so close.
Yeah, no problem. Hi, everybody. My name is Kurt. I am the planetarium engineer at Youngstown State University. Unfortunately, at the moment, that means I don't have much to do because of the fact we had a fire in January in our roof. So right now, the damage was such that they have to take our dome down to get at it. So we are not doing any public shows in the planetarium. When we reopen, which will probably be the second half of 2024, somewhere along those lines, we do have free public shows every Friday and Saturday at 8. Those are for general audiences. And then Saturday afternoons at 2 o'clock, we have shows designed for our younger visitors. So if you are in the Mahoning Valley, we love having people come out. I wish we could do this there because our Cronus is a wonderful resource to show you the night sky. And actually, I'm very happy that Abbie invited me because I haven't had many opportunities to do Star Talks over the last 7 months with the fire and everything like that. I first want to say happy 54th anniversary of the moon landing. On this day in 1969, Neil Armstrong and Buzz Aldrin set down on the moon. That would have been about 4 o'clock Eastern Daylight Time. They actually landed, so it was about this time of the night, 8 o'clock, 9 o'clock, that they actually left the lunar module and went out onto the moon. So 54 years, and I'll be showing you the moon in just a few minutes on our feed here. But I did want to talk about the resources that I mentioned before. The first one that Abbie and I were just talking about is called skymaps.com. If you come to the planetarium, we always print out a lot of these things and have them down at the front of the planetarium. It's just a simple PDF of the nighttime sky. And of course, my blue screen is cutting that off so you can't see it too well. The way these work is it's got a bunch of stars on there, and this is the way all star maps work, and it's not going to work very well if I can't get the light on it. What you do is when you go outside, you put the direction you're facing at the bottom of the page. So say you're facing west, you turn the sky map so west is at the bottom. Then when you hold the sky map up like this, what you see on the sky map will be what you see on the sky. So that's how you use it outside at night. Here in the Mahoning Valley, I will apologize in advance if I get cut off. We have severe weather just north of us, and about 8:30 is when it's supposed to hit my location. So if I go off, you'll know why. However, I say that because these will be great to use this weekend. Here, the weather is supposed to be fantastic this weekend, so you'll get a chance to use that. The other resource is the one I'm going to actually be doing the Star Talk with. It's a program called Stellarium. Now, there are two ways you can do this. You can download Stellarium onto your computer. It is free. You got to know what kind of computer you got, and if you have a PC, you got to know if it's 64-bit or 32-bit. There are different versions. Those are a little more capable than what I'm going to be using for tonight's show, though. I am going to be using the web version, which I'm not as familiar with as the downloaded one, but we could not get the stupid thing to pick up on the share screen right. So we're going to be using the web one, which you will be able to follow and my mouse so you can see what's going on with that. If you guys have any questions as we go through, Abbie is going to be our moderator. Abbie, feel free to kick in and ask any questions as they go along. I am going to be saving time at the end for questions as well. So, and you'll be hearing that as the night goes on, because that's my weather alert. And if there's a severe thunderstorm warning or a tornado warning, I wanted to be sure to hear it. So you might hear that in the background as the night's going on. But we are going to start this evening as if there aren't severe thunderstorms around. It always happens, you know, if I plan on getting out a telescope, my very first telescope I had at a museum, I called the Rainmaker, because whenever I planned on getting the thing out, that's when it would rain. And it looks like the same is true of a Star Talk as we go through here too. So I'm going to be sharing my screen with Stellarium, so you can see it here. And where we are starting is 9:30 this evening here in the Youngstown area. Now, if you aren't in the Mahoning Valley, you can actually set this for whatever location you're at. This is pretty much the same. We're at 41 degrees north latitude here in Youngstown. So pretty much the whole northern half of the United States is pretty close. Even when you get down in the southern United States, things will be a little bit higher than they are here, but it's still very similar. You'll be able to use this as we go through. I'm setting for 9:30, and you'll notice that you still see the glow over here. Official sunset tonight is at 8:50 p.m. The longest day of the year was back on June 21st, almost exactly a month ago, when we had the summer solstice. Our days are getting shorter and shorter. We're losing about 5 to 10 minutes of daylight a week right now. So sunset is going to be at 8:50. You will not be able to see stars in the sky right at that time, though, because the sky is still too bright. It won't be until about this time, 9:30, that you'll be able to start picking stuff up in the sky. And it won't be until closer to 10 that you're going to see everything you're going to see in the nighttime sky. But let's go ahead and take a look in here. And that's going to get annoying. I think I'm going to mute that. Give me 1 second here. X. Yeah. Okay. There. Now it won't do that. Okay, so I'm going to start in the western sky. And I think you can see right away why I am starting in the western sky at this time. The reason I'm starting in twilight is because of that guy right down at the bottom there. That is the planet Venus. And we were talking about the moon. There is the moon right there in the nighttime sky. Interesting fact that you will see on your sky map if you look today, the moon is at apogee, which means it's at its furthest point from the Earth in its orbit. Its orbit is almost a circle. It's just a little bit egg-shaped. So sometimes it's a little further away from us. Sometimes it's a little bit closer. Because of that, that's why you sometimes hear the hype over the supermoon. The supermoon occurs when you have a full moon and the moon is at perigee, its closest approach to the Earth. For the time. So right now it's at apogee, and we have just a very, very skinny little crescent of the moon here. Now, when you do have a clear day, you can actually see the moon during the day. Even though all it's doing is reflecting sunlight, it is the nearest astronomical body to the Earth. So it is the second brightest thing in the sky after the sun, and very easy to pick out. Now, one cool thing you can do with the Stellarium program here, I'm using the scroll wheel on my mouse. If I zoom in, you can get a look at what it would look like if you had a telescope looking up at the nighttime sky. And actually, it's really cool to look at the moon when it isn't full. What you want to look for is this line where the light separates the dark. That is called the terminator. And when you look at the terminator, you can actually see down into craters. You can see mountain ridges. It's really cool to look at that edge with a telescope or a pair of binoculars. It's a real simple target to hit. And no matter where you are, you can see the moon as long as you've got clear skies. So it's a good target.
Is that where I would find the Skynet with the Terminator line on that moon?
Could be another franchise there cutting over in there. I'll be back. We'll get to Mars in a minute, but anyway. But I want to pull back a little bit because there is actually a nice little conjunction in the western sky. The reason I said it so early is Venus is down here. Venus is the third brightest object in the entire sky after the sun and the moon. It is our nearest neighbor in space, and it is about the same size as the Earth and completely covered in clouds that reflect a lot of sunlight. So it is the third brightest object. This thing will look like an airplane that's just sitting still and not moving in the nighttime sky. Now, for most of the summer so far, it's been nice and high in the western sky as the sun sets. But right now, the sun is catching up with Venus, and Venus is starting to go around the other side of the sun. So we're starting to lose Venus in the glow of twilight. Now, I can't show you because this tree is in the way, but also up here, over here, is probably the most elusive object that you can see in the nighttime sky without the use of a telescope or a pair of binoculars. That's Mercury. Mercury is a fairly bright planet, but it is also the closest planet to the sun. So it's always never far from the sun, and you're always looking for it in conditions like this. I've been an astronomer for 30 years. I've seen Mercury myself in the nighttime sky a grand total of 8 times in 30 years. It is a tricky target to hit. A couple of days later, from now, on July 27th, Venus and Mercury will be almost right on top of each other in another conjunction. So it's a good chance to catch that, but you got to go out right at twilight between like 9 and 9:30 and try to catch Venus if you're going to catch Mercury. It is a tricky target in the nighttime sky. But much easier to see once it starts getting dark, though, is the planet that most people are like, and that is Mars in the nighttime sky. And as I pull in here, this one will even show you the 2 moons of Mars, Phobos and Deimos. You have to have a really, really good telescope to see those. They aren't very bright in the nighttime sky. This would be a really, really, really good telescope to make Mars look like this in your nighttime sky right here. But it will still be a bright red dot up there. And it's quite a bit dimmer than the moon and Venus, but still one of the first things you're going to see outside in the nighttime sky. I will point out to you, too, there is a star right here. It's not nearly as bright as Venus, but it is very easy to spot. That is Regulus in the constellation Leo the Lion. I'm not going to go into Leo tonight, but it makes this nice little pattern over here in the western sky as the sun goes down tonight. And that'll work here online, but you probably don't have a big red W in your backyard to help you figure out where you're looking in the nighttime sky. From your backyard, you might know which direction is which. That's terrific. But the night sky can also help you figure that out. And to do that, I'm going to move us around here, and I'm going to move us fairly slowly so I don't give anybody vertigo. It's a much bigger problem when you're under a dome and you're doing this and it's an immersive thing. And then I am going to come over here and I am going to move us ahead in time a bit. And we are going to go ahead to 10 o'clock this evening when we have full dark. Like so. There we go. Number 1, too, this, when you start it up, will keep track of the time, so what you're seeing on the screen will be outside. This is also useful if you're outside looking at the nighttime sky. You can go to this red mode. Red light does not hurt your night vision, so you can actually use this outside to look for stuff. You look up and see something in the sky, you can set your stellarium up to show you what you're looking at in the nighttime sky. But I'm going to bring us up like this. I pulled us back a bit so you get a fairly wide view of the sky. Remember, Venus now is about set. There's the moon, there's Mars. They're over just north of west. Where you want to look here in the northern sky is just west of north. Right here, we have 3 stars that make a handle and 4 stars that make a cup. And for anybody that's ever been in a planetarium before, you'll probably recognize that. That, of course, is the Big Dipper. And the Big Dipper is important for a couple of reasons. First off, the Big Dipper is bright enough that even when you're around the lights of a city, you can still pick it out. It's bright enough you can see it no matter where you go. Second of all, the Big Dipper is always going to be up in this part of the sky someplace, unless say you're down in Florida or something like that. It might go down below the horizon a little bit at that point. But for most of the United States, it is always above the horizon and bright enough you can see it from wherever you are. Because of that, we can use the Big Dipper to find the most important star in the sky. What we are going to do is take these two stars at the end of the Big Dipper's cup. Now, outside of tonight, you can't put a cursor up on the sky to do this with, but you can do this with your eyes as easily as I am with my mouse. Just draw a line from the star at the bottom of the cup through the star at the top of the cup, follow that across the sky. And the next bright star you're going to come to is right here. That star is called Polaris. And most of you know that star better as the North Star. A lot of people think it's important because it's the brightest star in the sky. But if you look around, there are a bunch of stars up here that are all brighter than Polaris. What makes it important, though, is where we find it in the nighttime sky, and that is directly above the North Pole of the Earth. Well, what's the big deal with that? To understand that, you got to know a little bit more about how our planet works. The Earth spins in space like a top on its axis once a day. As a matter of fact, that is how we define a day, is how long it takes us to turn around one time. To give you some idea how fast that is, if you were to measure the Earth around at its equator, that's called its circumference. The circumference of the Earth is just a hair under 24,000 miles. So to get around once in a day, the Earth is literally spinning at 1,000 miles an hour. However, you and I are really tiny compared to the Earth, and we are on the thing that's spinning. And since the Earth does not speed up and slow down like your car, we don't feel that motion. However, we can see that motion if you look at the nighttime sky. Because we are spinning counterclockwise on our axis, everything in the sky, sun and moon included, appears to rise in the east. It slowly drifts across the sky in a curved path we call a parabola, and then everything sets in the west. But that stuff really isn't moving. It's pretty much staying put. What moves is us and makes it appear like all that stuff's moving. And I just lost Polaris. So there we go. Get back to Polaris right here. So now what's the big deal with Polaris? The North Pole is the top of our planet's axis. So I've marked Polaris there. I'm going to move us ahead in time a bit. And look what happens. That star stays put while everything else in the sky appears to turn around it. So it doesn't matter what time of the night or what time of the year you're looking at the stars. As long as you can find the Big Dipper, take those two stars at the end of the cup, draw a line across and find Polaris, that star will always tell you what direction you're looking. That is, of course, north. So there you go. There is your marker in the nighttime sky that can help you find things up there. Now, as I mentioned, I'm showing you the sky over Youngstown here. So you see this glow down along the horizon. We are in full dark now. However, that glow comes from all the lights that are around the city. That is called light pollution. And unfortunately, in light polluted conditions, you just can't see everything there is to see. I'm going to stop sharing this for a moment, and I'm going to share something else with you. This is from a great website called Info. This is also an interactive map. You can find your location on this very well. But this is the sky over Northeast Ohio. When you're looking at this map, sky brightness, when you get into the reds, the purples, and the whites, that's bad. When you get down toward the blues and the greens, that's good. And here we are in Youngstown. We're under a whole lot of bright lavender here. So we got a light here. As you look at this map, if you head up toward Cleveland, forget about it. You're going to be in light pollution the whole way. If you get up into northern Trumbull, this wouldn't be too bad as skies up in here. Down into Columbiana County, down in here, This, especially right in here, is good skies. There's a good state park down here I've gone to a couple of times in Columbiana County. And then if you go east over into the Allegheny National Forest, also known as the Laurel Highlands of Pennsylvania, that's also a good spot to look at the nighttime sky as well. But here in Youngstown, we are kind of stuck with our bad lighting up there in the nighttime sky. And I kind of got to be able to see what I'm doing here. Okay, share. There we go. It does make it a bit difficult to see things. Well, luckily here in our program, I can do something about that. I can click that off of there. And this is what the nighttime sky would look like if you could get away from all of those lights in the nighttime sky. Western United States is a lot better than we are here. The Eastern United States is very highly populated. The thing that sucks about light pollution is it's actually really easy to fix. All you got to do is put a shield on the light so it shines the light down on what you want instead of up on the sky. When you do that, you can use a much lower watt bulb and get the exact same result. That actually saves a lot of electricity as well. Campus drives me crazy. A few years ago, they got rid of all these old mercury pressure lights around campus, and I was celebrating when they took them down, like, oh, good, getting rid of this. They put LED lights that are 3 times as bright at all the location where the sodium pressure was. So now YSU's campus is lit up like a basketball court, and it's even worse than it was before. They are full cutoff lights, but I haven't yet found a spot on campus where we can't just go, there's the moon, thanks for coming, for a star party. So we do what we can. All right. Let me go back to the Big Dipper, which is a little easier to see now, right here. And I think if I do that, and then I do that, oh, it does all of the overlays. I can't do individual ones. Oh, well. But the Big Dipper's there. Now that it's dark, I can show you the constellation that Polaris is in. That is called the Little Dipper. Polaris is the end of the handle. The handle curves around like that. And there is the cup. And for being one of the more famous constellations in the nighttime sky, that is a wimpy little thing, isn't it? As a matter of fact, if you are around lights tonight and you're looking for a Little Dipper, all you're going to see are Polaris here and these 2 stars at the end of the cup we call the Guardians. All these stars in here will be too faint to see. But the reason everybody knows the Little Dipper is because it is the home of the North Star. That means it's always up in this part of the sky. So if you're at a reasonably dark location, it's usually pretty easy to pick out. Now, I told you that Polaris is not the brightest star in the sky. It's actually the 48th brightest star in the sky. We astronomers actually rank stars by how bright they appear in the sky. The very brightest stars we call first magnitude stars. There are 26 of those in the entire sky. Now, some of those we never see here in Northeast Ohio. They always stay below our horizon. Others you only see in the fall or the winter or the spring or the summer. They change as the season goes on. I said Polaris is the 48th brightest star. It's in the next rank of stars that we call second magnitude. The dimmer a star is, or the dimmer the object is in the nighttime sky, actually, the higher its magnitude number. Just for your future reference, if you're at a really dark location and you're not using a telescope or a pair of binoculars, the dimmest objects that your eyes can detect that you can see with your unaided eyes are down around 6th magnitude. If you're at a really dark place and you have really good eyes, you may see down to 7th, but usually 6th is about the cutoff for that. I do not have good eyes. I'm lucky to see 5th magnitude, 4th magnitude with my glasses and everything with that. Now, the reason I bring this up is the Little Dipper is a really handy thing to tell you how good your sky conditions are where you're at. I mentioned Polaris here. I'm going to zoom in so you can see this a little bit. Polaris here is a 2nd magnitude star. Kochab here is a 3rd magnitude star. This one up here is called Farkad. These names are Arabic. I'm not so good with the Arabic names. This is Farkad. Farkad is a 4th magnitude star. This one is Gaia. That one is Zeta Ursae Epsilon, and Yudun. Like I said, please pardon my Arabic, but this one and this one are 5th magnitude, and this one are 6th magnitude. So depending on how many stars of the little oh, it just moved me. Sorry about that. Still learning all these things on here. Depending on how many stars of the Little Dipper you can see, it will tell you what we refer to as the limiting magnitude, the dimmest stuff you can see in your current nighttime sky. So that's a handy tool to have in the nighttime sky.
Kurt, we did have a question.
Yes.
Is the Big Dipper part of Orion?
No, actually. The Big Dipper is actually part of a much larger group of stars that we call Ursa Major, which means the large bear. Most of the rest of the bear is too dim to see in light polluted conditions. That does bring up something else, though, because the Big Dipper is an easy to spot pattern that isn't a constellation. We have a different name for the Big Dipper and things like that. We call it an asterism, and I will be showing you some asterisms as the night goes on, too. Orion the Hunter is one of our wintertime constellations. And the reason for that is right now, the sun is almost directly in front of Orion the Hunter in July. We cannot see Orion in any part of our sky at this time of the year. He'll start rising again in our evening sky around November or so, and he'll be up until about, say, late May. That's the time of the year. That is by far the most recognizable constellation in the sky. He has 3 first magnitude stars in him, but those are 3 stars you can only see during the winter time. Now, getting back to our asterism, the Big Dipper here, the way I found the North Star is a highly technical process that we astronomers employ known as a star hop. And all that means is if you know how to find something like the Big Dipper, you can then use it to move around and find lots of other things. Well, as it turns out, the Big Dipper here is probably the best thing that you can ever learn in the nighttime sky, because there are a ton of star hops you can do off of the Big Dipper. It is like a key that will unlock the entire nighttime sky. Any time of the year you're looking at the stars, you can use the Big Dipper to find something in addition to the North Star. For example, at this time of the year when it's high in the northeast, we can take the handle of the Big Dipper here, and we can follow the curve of the handle, and I'll grab the mouse, and follow the curve of the handle or make an arc, and we will end up at this bright star right here, which is called Arcturus. And what I just did there is I arced to Arcturus. We astronomers are kind of absent-minded. We need these little things to remember these star hops. We find Arcturus in a constellation I have always had a bit of a problem with called Bootes the Herdsman. Now, I don't have a problem with Bootes because it's a dumb name. Actually, you could call it Booties if you want to. It's one of the dumbest names in the entire sky. No, my problem is I don't know any herdsmen. So when I see Bootes, I usually picture something a bit more familiar. And for those of you who do live here in the Mahoning Valley, you'll probably see this too. There's Arcturus. That's the base of a cone right here. And I just noticed something that's on there. See if I can figure out how to turn those off. Yeah, these little things you see here are actually satellites that are up above that you could see in a telescope, I guess. But that's Arcturus. That's the base of a cone right here. Here's a scoop of Handel's ice cream on that cone. And everybody knows how big Handel's makes their ice cream cones, but it used to be a double-decker cone, but his scoop has fallen off and is lying next to it over here. I think that's a little easier to see than a herdsman by myself. By the way, that scoop that fell off, that is another constellation. It's a little constellation with a great big name. It's called Corona Borealis, which means northern crown. Corona, like the beer, means crown. Borealis, like aurora borealis, means northern. And according to the Greek people in one of their stories, Hercules was supposed to have thrown those stars up there a long time ago. Now, Arcturus is actually the 5th brightest star, the 4th brightest star in the entire sky. So it's likely to be one of the very first stars that you see outside at night. However, it's not the brightest one that's up in our summer sky. And I'm going to get us turned back around here to the north, and I'm going to back up a little bit. There is one pattern that is very, very prominent at this time of the year. You'll have no problem picking it out even without star hopping. I'm going to star hop to it, but you won't have any problem seeing it. We take these 2 stars at the back of the Big Dipper's cup that we haven't used yet, and we're going to draw a line just like we did to find the North Star, from the star at the bottom through the star at the top, follow that across the sky. And when we do that, we're going to hit the 4th brightest star in the entire sky right there. That star is called Vega. And Vega is found in a really easy to spot asterism in the nighttime sky. We have 3 very bright stars at this time of the year. I pulled back a bit too far. This is about halfway up the sky in the east, right about 10 o'clock, which is where I have us now. And that star is, we call this asterism the Summer Triangle. Go figure. Now, it's actually a lousy name because it's going to be in our sky well into December, but it's highest in the sky during the summer, hence the name. The Summer Triangle, though, isn't an asterism because it's part of a bigger constellation. Each of these 3 bright stars finds its home in a different constellation. This one's called Vega. This one down here is called Deneb. And this one over here is called Altair. But I'm going to start us with Vega. And you can see the 3 constellations right here. Vega finds its home in a tiny little constellation known as Lyra, the harp, in the nighttime sky. I don't think it looks much like a harp, but if you go out there, there are 3 small stars that make a small triangle right there, and then 4 stars that make what I call a parallelogram. You can call it a rhombus too, if you prefer that. So that's about all there is to it. It's one of the smallest constellations area-wise in the entire sky. We come down to Deneb here. And Deneb is found in the constellation of Cygnus the Swan. And this one's really easy to spot, actually, up in the nighttime sky. You can see the swan shape very well. We can actually shorten that swan down and make another asterism right there that we call the Northern Cross as well. But while we're in Deneb, I do want to point out this star right here, which is called Albireo. That is Albireo. Why is it saying Gaia DR whatever? Anyway, Albireo is my favorite star to look at in a telescope in the nighttime sky. Right now, when you're looking at it, it just looks like a single star in the nighttime sky. But if we zoom in on it, it should do this. Yeah, there we go. Now it says Albireo. There we go. When you look at it with a telescope, it divides into 2 stars. Now, this program isn't doing this, but the main star is a golden yellow, and the second star there is a bright blue. It's a beautiful pair of stars to look at in any telescope. Our star, the sun, is a single star with all the planets going around one star. As we've looked out into our galaxy, though, we've discovered that's actually unusual. Stars form together in big clouds of gas called nebulae, and because of that, they tend to group up in 2s, 3s, and 4s. So it is much more common to see solar systems out there that have 2 or more stars in them than our single star like we have. So that's Albireo. Last but not least, let's come down to Altair over here. What? Oh, no, that's not Altair. That's right. There's Altair right there. We find Altair in probably the hardest of these 3 constellations to see. This is Aquila the Eagle down here. And if I kind of, I don't know if I can turn this the right way, but I kind of picture him as one of those Southwestern Native American drawings. He's standing straight up and down. There's his head right there. 1 wing, 2 wings, kind of like the crest of the president of the United States or the back of the quarters before they started doing the state thing. That's 2 other ways you can look at him right there in the nighttime sky. So even if you have a hard time seeing those out there in the nighttime sky, from Altair to Vega to Deneb is really easy to see, especially though if you are around light pollution. Let's go back into lights for just a minute. Look how that triangle pops out at you when you get around lights. Now that's really unusual. 9 times out of 10, it's easier to see stuff when you're in a really, really dark location. But that's not the case here, because when you're someplace dark, there's this cloud that is cutting right across the top of our triangle, makes it difficult to see. Well, that isn't really a cloud. That, of course, is the Milky Way. And they named the candy bar after this, not the other way around. But what you're looking at there is part of our galaxy. The Milky Way is the galaxy that we live inside. A galaxy is a huge collection of stars. Our Milky Way has somewhere between 100 and 300 billion stars in it, with a B that we estimate. And it's what we refer to as a spiral galaxy. It looks like a big pinwheel spinning out there in space. All the stars that you see in the nighttime sky that are points of light are all stars in the same spiral arm as us and our sun. Everything I'm showing you here are our near neighbors in the Milky Way galaxy. But when you're looking at this cloudy thing through here, you're actually looking at other parts of our galaxy. For as wide as it is, the galaxy is actually very skinny. So most of our galaxy lies in this direction of the nighttime sky. So that glow you see is actually lots and lots and lots and lots of stars. But those stars are so far away from us, we can't see them as individual points of light. Instead, their light blends together and makes this glow you see. Kind of like when you're a long way away from a town, you can see the glow of it on the horizon, but you can't make out the individual lights in the town. Same type of deal going on here. Now, the Milky Way in our sky is somewhere around 5th or 6th magnitude. So if you are around light pollution, you will have no hope of seeing the Milky Way. As a matter of fact, a recent survey of the United States has shown that 80% of the population of the United States can no longer see the Milky Way in their nighttime sky due to that light pollution junk I was showing you a little bit earlier. But the flip side of that coin is if you are someplace you can see the Milky Way, you know you're at a good location to look at the nighttime sky. So that's the Milky Way there. Now, you might not have heard of the constellations of Lyra, Cygnus, and Aquila before. Lyra the harp, Cygnus the swan, Aquila the eagle in the nighttime sky. But there are two very famous and very easy to spot constellations up in our summertime sky. I'm going to bring us down here to the southern sky. So we have in the south, and if we come right down the Milky Way from the triangle, the brightest star down in this part of the sky is right here. That star is called Antares. Now, Aries is the Greek word for Mars. So Antares or anti-Aries literally means the rival of Mars. This star is the same color and about the same brightness as the planet Mars in our nighttime sky. And when Mars eventually moves from here over to this part of the sky, it is easy to get them confused in the nighttime sky up there. You know what? I want to move ahead just a little bit because there is another planet I want to show you in the nighttime sky. So let me move ahead just a smidgen here. Also make that a little easier to see. Well, it looks like I'll have to do that a little bit later. We'll come back to that in just a moment. Aries, Antares, is found in a very large but very distinct constellation known as Scorpius the Scorpion in the nighttime sky. He is very easy to spot even without that outline. Antares is right there. That's his heart. Antares also means the heart of the scorpion. We sometimes call it that. And Scorpius has one big old nasty claw right there. One big old nasty claw right there. His body starts above Antares, curves down like this, and there's a stinger right there. In Polynesian cultures, this is Maui's fishhook. If you saw the movie Moana, you might recognize that. This is Maui's fishhook. And according to that legend, Maui was out fishing one day and his hook caught on the bottom of the ocean floor, but he thought he hooked a really big fish. So he yanked and pulled and tried to get this fish up, and he pulled the Hawaiian Islands up out of the ocean with this fish hook, and that's fish hook he used. So that's kind of cool too. You're welcome. Anyway, but as a scorpion, he looks really big, mean, and nasty up here in the nighttime sky. But don't worry, we have a hero to protect us from the scorpion, because right behind him over here is Sagittarius, the archer in the nighttime sky. Now, here in Youngstown, we never get to see all of the archer. Most of his He's known as a centaur, which is a mythological creature that is half human, half horse in the nighttime sky. The horse half we never get to see well because of his position in the sky. These constellations do not stay up long in our nighttime sky, and they're very low on the horizon. So usually the horse half is below the horizon for those of us here in the northern United States. But we can see the important parts of the Archer. These three stars are his head. These three are his bow. He has an arrow on the bow right here. And this is his arm pulling back the arrow as he gets ready to shoot it over at the scorpion. Well, at least that's what the ancient Greek people saw. But I think they saw an archer because back in ancient Greece, they didn't have teapots. Check this out. Here's a little teapot, short and stout. Here is the handle, and here is the spout. Yeah, and look, it's even got steam coming out of the spout. How about that? So there you go, the teapot. And that is yet another asterism. You will see the teapots marked on a lot of star charts because it is a very distinct pattern. You'll have no trouble spotting the teapot or Antares even in light polluted conditions as we go through. Now, here's something you can impress your friends with this summer. If you come off of the spout of the teapot until you're right over the stinger of the scorpion, right there where I've got my mouse, right there is the center of our galaxy. The center of our galaxy lies right there. Now, we can't actually see it from here. It's a long, long way down to the center from where we are, about 250,000 light years. And there's a whole lot of stuff in between us and there. Now, I say we can't see it. Astronomers just last year actually imaged the center of our galaxy. It's called Sagittarius A star, as in the asterisk symbol. And it is a supermassive black hole down at the center of our galaxy that keeps everything else moving around it. Don't worry, we're not going to fall in. But they used a brand new imaging technique using radio telescopes from around the world and basically turned the width of the Earth into a giant radio telescope. Took lots and lots and lots of data, and they actually have an image of what Sagittarius A star looks like down there. So that's really cool too. But for you and I, we can't see it with just a plain old telescope. But say you're at a party this summer, you can find Scorpius, you can find Sagittarius, you can go, hey, I know where the center of the galaxy is. Guaranteed to impress, at least at the parties I attend anyway, in the nighttime sky. So that is two very famous constellations in our summer sky. There's what I was looking for. I'm going to run just ahead in time a little bit more because there's just two last things I want to show you. You'll see I'm moving ahead here. This is about 11 o'clock this evening, and about that time, rising in the eastern sky is my absolute favorite planet in the nighttime sky, about the same brightness as Mars, except this one is golden in color. That is Saturn. Now, when you're just looking up in the nighttime sky, this is what Saturn will look like. It's just a bright dot in the sky. But it is my absolute favorite thing to hit with a telescope or a pair of binoculars, because then you can see the rings of Saturn. Even a small telescope will show you a line across there where you can see that. Binoculars are a little bit jerky to see that, but you will be able to see that. When you get bigger telescopes, you can actually see the division in the rings. We call that the Cassini division. And I have looked through one big honking telescope that was 22 inches across. The mirror was 22 inches across. I could see two ring divisions. For most people in the backyard, though, you'll be able to just see the one. You might, this is one thing I'm not good at. If you ever see Jupiter, which is in our very early morning sky, it's very easy to pick out the four major moons of Jupiter. Here, Titan's pretty easy to see, but because of the way Saturn lies, I always get confused between Titan and another star. The planets around here just look like dots, and they don't stand out nearly this prominently when you're looking through a telescope. The rings do, though. Now, when I've moved us ahead to 11 o'clock, let me keep pulling back here. That's in Aquarius. Keep pulling back, keep pulling back. I'm going to come up to the northern sky again. Oh, and I don't have them above the horizon yet. Well, right about here, I don't think I can do that here. when I'm in the program that shows the one that you can download, I can actually show meteor showers. And we are just at the beginning of a very famous meteor shower. We have just entered the Perseid meteor shower. And it's called that because if I go ahead an hour, that should help. About there's the constellation Perseus. The center of the meteor shower looks like it's coming out of here. Now, any given night you're out looking at the nighttime sky, if you're at a dark location, there's so much junk in our solar system. These little rocks hit our atmosphere. Meteors are just basically little rocks that are burning up in our atmosphere as the Earth plows through space. Any given night, you can see 3 or 4 an hour. But when a meteor shower happens, they tend to clump up. By the way, until the early 1800s, meteors were considered a weather phenomenon. Hence, people who studied meteors were meteorologists. So the meteorologist you hear actually goes back to that because it used to be part of weather as we go through there. Now, where these come from is as the year goes on, we pass through the trails of comets. Comets are big, dirty snowballs. So when a comet comes into the inner solar system and gets near the sun, what do you think is going to happen? It's going to melt. It doesn't melt all the way, but it does leave a trail of debris behind it. The Perseid meteor shower was laid down by a comet called Swift-Tuttle. It comes back about every 20 or 30 years and replenishes the stream. And we cross the debris path through this time of the year. Right now, you could go out and see some Perseid meteors in the nighttime sky. From about mid-July is when we enter the stream. The peak, though, is going to be August 12th, the night of August 12th into the morning of the 13th. And that's actually good because the moon will be in the waning crescent phase. And so it doesn't come up until an hour before sunset. So we're going to have moonless skies. So the moon will not interfere with your view. On the peak night, this is a very consistent shower. When we're going through the center of the debris field, we can see up to 90 meteors an hour if you're at a dark location. Probably in the city, you're going to be lucky to see 40 or 50. Now, you don't need a telescope or a pair of binoculars in order to see meteor showers. Matter of fact, the one thing your eye is better doing than anything else is picking up motion. So to see a meteor shower, what you want to do is find a really, really dark location where you don't have much horizon and much above you. You want to have a nice wide view of the sky. Just put out a blanket, put on some mosquito repellent, and then you just slowly start scanning your eye back and forth across the sky. When you do that, you'll start seeing these little streaks in the sky. Sometimes they'll just be up there for a second and they'll disappear. Other times it'll go all the way across the sky. These are little tiny rocks. Most of them are about the size of a Rice Krispie. The bigger ones might be about the size of a pebble. They can be as small as a grain of sand, but they're hitting our upper atmosphere at around 6,000 miles an hour. When they do that, they get white hot and vaporize in the atmosphere, and that makes the little streaks in the sky. And your eye will just naturally pick these up as they go through. The reason it's called the Perseid meteor shower is even though they're all around the sky, as we're heading into things, it's kind of like when you're driving in the snow and the snow's coming down, but when you're driving, it looks like you're driving through the tunnel and it's all coming right at you. That's because the Earth is moving. So they all look like they're coming out of this part of the sky right here. That's called the radiant. They will be all over the sky, but they'll all look like they originate right about there. So you can check those out anytime. The peak's around the middle of August, but anytime between now and the beginning of September, you can actually check out the Perseid meteors in the nighttime sky. So I am going to stop sharing my screen now. I know that is a lot of stuff. My goal here, though, is not to try to make you remember every last little detail. That's rather beside the point. That's one of the reasons why I direct you to sky maps as well, so you can find this stuff on your own in the nighttime sky. What I hope you will do, though, is the next time you're outside and the stars are out, look up. Look around for Mars and the Moon and Venus and Saturn. Find the Big Dipper. Look for the North Star. Maybe you're even someplace dark enough to see the Milky Way. The nighttime sky always changes over your head, and I hope that gives you a starting place where you can go out and explore it. It's a lot of fun to do that. So there you go. If anybody has any more questions, I am happy to answer them for you. So just pipe up, or Abbie, if you have any that popped up there, I'm happy to answer any questions. Oh, Northern Lights. Okay.
North. Okay. Thank you.
Yes, that's also known as Aurora Borealis. What happens there is the sun kicks out a huge amounts of material off of it. It's called a coronal mass ejection, and these are high energy particles. They interact with the magnetic field of the Earth. So they come in at the north and south poles where the magnetic poles are, and they come down, they excite the molecules in our atmosphere. And when that happens, it causes this glow. I have actually been lucky and have seen the Northern Lights exactly once in my life. They are fun to watch. Usually you have to be pretty far north in order to see them. But I was lucky. I was literally at a star party with 50 or 60 other amateur astronomers in northern West Virginia, and we saw the aurora. It was spectacular.
Cool. Yeah, he says those are the Northern Lights over Minnesota 2 months ago.
Awesome. Yes,
Cool.
we actually are in the middle of a, like I said, high solar activity. Another great website is called spaceweather.com. It's actually run by NASA. They monitor the sun, and they actually give alerts when there's a chance of seeing aurora from spaceweather.com.
Thanks for sharing that with us.
Yes.
Does anybody else have any questions, any comments? I know, like, I'm always very interested in the constellations and how they got their name and how they're all interconnected. But I was always, you know, a mythology geek when I was growing up too. So I had no idea.
Let me tell your folks that the modern soap operas have spaceweather.com. Spaceweather.com is the one for looking at solar activity. There you go. Thank you. But yeah, the modern soap operas got nothing on the ancient Greeks when it comes to the stories. There are constellations actually go back. Actually, one thing I will tell you, this is really interesting. Ursa Major, the big bear, the tail of the Dipper is the long tail of the bear. The Greeks weren't the only ones to see that. Actually, several different Native American cultures also saw a bear with a long tail in that part of the sky. Now, how can that be? It's possible that that constellation actually was created and passed down from people to people before humans crossed the Bering Strait over into North America. If that's the case, that constellation may be one of the oldest creations of humans still in existence today. That we pass down with that. So the main bulk of our constellations, 44 out of the 88 constellations, though, came to us from the ancient Greek people. So most of what I was showing you tonight were all Greek originated constellations. The official 88 constellations were adopted in 1921 that we use today. And some of the ones in the southern hemisphere that the Greeks couldn't see, we have some interesting things like the microscope, the fly, the air pump, some things like that were created in the late 1800s. But a lot of the Greek ones especially have stories that go with them. I have a great story for the fall sky too. Yeah, the fall sky. That's the Perseus and Andromeda story. It's a lot of fun.
Okay, cool. All right. Well, I went ahead and put the websites for Stellarium as well as Sky Maps in the chat too. So, and I know I put those out in the email as well for anybody, you know, go back and check your email. Oh, Sally says, how do I find nebulas?
There are a few you can see in the nighttime sky. The very easiest one to find is in the constellation Orion in the winter sky. It's called the Orion Nebula. It's just below his belt. Very easy to pick out. Let me think of ones in this part of the sky. There aren't a lot in the northern sky that you can see very clearly without a telescope. The best place to look in this part of the sky is towards Sagittarius and Scorpius. There are a bunch down in that area, but you really need a telescope in order to see them. But because the center of our galaxy lies that direction, there's more stuff in that direction than anything else. If you really want to impress somebody like the nighttime sky, just find those two and put a telescope down there and just say, hey, I want to show you something neat. And just start scanning down there. You're going to hit something cool that you can show people like that because there's so much stuff down there. There is a star forming region in Sagittarius. Let me see if this shows it well. I'm going to go back to my screen share here. There we go. Oh, and the storm, I'm getting some thunder here in Austin town. Yes, right here is the top of the teapot. There's the spout. There's a nebula right there. And I think I can click on, no, it's not going to let me get in there too well. That's a star forming region right there. And it's called the Rosette Nebula. And that one's actually not too hard to hit with a telescope. It won't look red like this just from your backyard. Oh, that's why. Okay. So, most nebulas will look greenish white through just a telescope. It's when you take long exposures, you can see the colors in these things as we go through. So that's a good one to hit down there, the Rosette Nebula. I think I can.
She says, would I use colored filters?
Filters do different things. They have different filters for different uses. For example, Saturn is good to look at with a green filter because it allows you to see the different colors. There are specific ones that will knock down light pollution. I am not as good with filters as my boss is. He's much more adept at using those sort of things on his telescope. Oh boy, yeah, things have hit here in Austin town. But you can actually look that up. What filters should I look to see what type of objects? I will tell you, there are some great telescopes out there. I could do a whole show just on how to buy a telescope. There are some great things out there. Celestron just came out with one that we just got one of these telescopes. You take your cell phone, download a program on it, and then mount it onto the side of the telescope. Telescope has no motors on it, but your cell phone knows where it's looking through its camera at what you're looking at. And then it just tells you go left, go left, go left, go up, go up, go up. There, you're on it. And then you can look through the eyepiece and see it. It's called StarSense, Celestron StarSense. They have several of those. Fantastic innovation in the field. But there are tons and tons. Most people, the running joke in my field is most normal people buy cars, astronomers buy telescopes. So yeah, you can spend anywhere. You can. One thing I do not recommend is going over to Walmart and picking up one of the $25 or $50 ones. Those things are junk, and you won't see anything in them. You need to spend in the 200 to 500 range to get a really, really nice one. You can get starter scopes down around 100 if you have a younger child you want to show stuff. They have some good ones in that range. But yeah, you can go up for upwards of $5,000-$10,000 if you want to on a telescope. And there are some amateur astronomers making major contributions to the field of astronomy because of the huge rigs they've got in their yards now. So
yeah, Sally says she has an 8-inch reflector.
That's an excellent scope. That's exactly what we just got in the StarSense, is an 8-inch reflecting telescope. So yeah, you should have no trouble picking out the Rosette Nebula with an 8-inch. You'll see the rings of Saturn really well in that as well. There are a lot of Alberio looks fantastic in an 8-inch telescope. Now, the way telescopes work is the bigger around it is, the more light it gathers, the more you're going to see. You control the magnification though with the eyepiece. So you don't just want to have a great telescope and fair to middling eyepieces. You also have to invest in your eyepieces so you can see what you're looking at. And that whole nother thing right there.
Okay, Antonio asks, is it SN Lee EQ114 reflector telescope a good choice?
Refractor or reflector?
Reflector, I think. Right, Antonio?
Yeah.
Yeah.
If you just say it. Okay. 114 sounds more like a refractor to me. That would be lenses at both ends. If it's a reflector, that's a pretty small mirror at the bottom. I tend to favor reflectors simply because you get more bang for your buck. You can get a bigger mirror for less money than you can a refractor. So that's one of those. Yes, it's a refractor. 114 is actually a really good starter scope. Refractors are good for looking at nearby stuff, planets, the moon, things like that. They're excellent for that. When you're looking at deep sky objects, you want to gather more light. Reflectors tend to work better for deeper sky objects. Okay.
I don't see any more questions in the chat. I know we were recording this. Oh, Antonio says he's starting to learn it as a hobby. Very cool.
Excellent. One other resource I should mention in the area, if you are in the Youngstown area, the Mahoning Valley Astronomical Society has an observatory up near Newton Falls. You can find their website and get a hold of them. And they're the ones we have come out when we do at the planetarium. So you got a telescope, so you want a telescope, and they can help you learn how to use it. Their observatory is very nice dark skies for this area. So they're good folks to work with.
And we did have a question earlier about getting a recording of this. I know, Kurt, you are recording it.
Yes.
So
I will be posting this on the Ward Beecher Planetarium Facebook page and on our YouTube page, so you can check both of those out. I should be able to cobble this together tomorrow or the next day. It'll be up by the weekend for sure.
Awesome. Yeah, I'll make sure everyone gets that link. I'll check it out and send it on to everybody who registered to attend.
Very good.
So, okay. Well, unless anyone has any other questions, Kurt, any final words you want to close out with?
Like I said, I wish I could have you guys all come down to the planetarium in Youngstown. It's going to be spectacular when we reopen. Second half of 2024 is what we're shooting for right now. But hope to see you out. And by all means, go out and look up at the nighttime sky. You can do that anytime.
All right. Well, thank you so much. I'm not going to go out tonight. It's a little wet out there.
Yeah.
But, if it's not wet where you are, please go out and take a look. So thank you all for joining us. Thank you again, Kurt. This was wonderful.
Happy to do it.
Hopefully we'll see you in the fall.
Yes, absolutely. Not this fall, next fall.
Exactly. All right. Have a good evening, everyone, and we'll see you at our next event.